Welcome to the another session in Frontiers in CFD. So CFD simulation for thermal management of prismatic cell lithium-ion battery pack using pulsating heat pipe. So the preparation of geometry for prismatic cell lithium-ion battery pack using pulsating heat pipe, generate mesh and name selection on computational domain, applying the boundary conditions and visualizing the results. So this is one of the reference geometry which we are going to follow. Reference image I will say because we are not exactly doing the same but with some different dimensions. So this is how we are going to proceed. So we'll be having a pulsating heat pipe which is enclosed in a kind of a rectangular plate, and besides that we'll be having a kind of lithium ion cells. We are followed a particular dimensions. So dimensions image is this one which we are going to follow throughout. So it is around 105 by 70. So this is one of the a cell which is prismatic cell which is we have considered it as a dimensions, and accordingly the rest of the geometry has been prepared. So width of the plate which is 3 mm, so that is the plate which is containing the pulsating heat pipe, and width of the cell is the cell which is the prismatic cell which has the width around 18 mm. So accordingly the whole analysis has been carried out. So the geometry is slightly different than uh, the one which is showed in the previous slide. So here you can see it is completely enclosed in the, whereas in the previous slide you have observed it is slightly below that. So there are some variations, and accordingly we are trying to do the simulation. So this is the geometry we are following for today's simulation. So we'll be having 105 as this dimension here, 70 in the vertical direction, and this is 90. So these are the dimensions we are going to follow for preparation of geometry. So we'll start with the workbench. So we'll first prepare the geometry and then accordingly we'll proceed for the simulation. So through this geometry will be based upon this, we can say this is one of the reference. According to this we are trying to do, but we are going to do slight modification in the geometry as I said. So here this is the actual geometry which we are following, and accordingly we'll proceed with the simulation. Okay, so let's open the fluid flow fluent. So let's open the geometry. Let's start with the new design modeler. So first set the units mm. Just look at the plane. So here, so first of all we are going to prepare the 70 by 105. This is one of the box dimension. So create primitive say cylinder as a box. So x component will be equal to 105, y component will be equal to 70. So z component will take as 18 plus 18 plus, that is 36 plus 3, so that is equal to 39. So total dimension we are going to take. So here, so now we'll do some operation which involves slice. So first of all I will take one more plane. So create plane here. So base plane you will be your how you want to cut, so accordingly the base plane will be selected. So we are going to select xy only. So offset z by 18 here, first 18, generate. So here you will be having this one, then make it slice operation. So apply plane 4, so it will become slice. After that again one more time create one more plane. So plane 4, or you can take it both way, you can keep it plane 4 also. Only thing offset will be z, that is equal to 3. So now it is there. Once you are generated, do the slice operation with the help of that same plane. Now you can see here, so this is the cells which are been here, and in between that you will be having a plate. So in that plate we are going to create the pulsating heat pipe. So based upon that we'll proceed. So as of now we don't require this two solids, so we'll go on to hide this two, only we'll keep it or just a minute. Okay, so we want to keep this as of now. I will hide all the other one. So accordingly we are going to proceed. Now again, the thing is, we are going to have the diameter of the pipe as 2 mm. So accordingly we'll take so this is 3 mm, so we'll create one more plane which is at 1.5 from this. So let's say offset, so plane 5, you can say offset it again by z. So I'll put it minus 1.5 here, so it will go inside of this, so we'll get somewhere at the center. So make it here, so we'll have one more plane which is generated exactly in the inside. Now with reference to this, we are going to generate the sketch. Okay, so what we are trying to do is we are trying to prepare this one. So carefully observe the dimensions. So this is here, it is 5. So we'll be going here from this point to this point. This distance is, if you see this distance is 14.5. So from this point you can take it 14.5 and this is your 19 distance. Okay, so just check it from this again. If you see this one, this distance to this is 19 and this is your 14.5. So accordingly you can select. So let's proceed with this one. So I have a sketch on this plane. So click on sketch, draw a sketch. So from this point, so these are the 2 3 sketches are there. So plane 6, on this we are going to prepare the sketch here. So let's zoom in the portion which we required. First of all, draw the line. So we have horizontal distance that is equal to say 5, then vertically we are moving up by distance that is equal to 19. So let's move by distance that is equal to 19. Just a minute. So let's move vertically by 19. So from this we'll take it vertical. So the dimensions of this will be equal to 19 here. Then we need to draw a line from this horizontally that is equal to 9.5. So we'll draw a circle on this with diameter 19, radius 9.5. So diameter is equal to 19. So it will be a line which is going here in vertical direction. So this is 19 and this will be 51. Total is 70. So this is, if we take this distance and this distance is 19, so from this we need to 51 ahead. So that's accordingly we are taken V12 is 51. So similarly draw one more line from this here horizontally, then draw one more line which is vertical. Enter dimension is equal to 51. Remove the unnecessary things which are not required. So trim out the things which are not required here. So the sketch is generated. Now we'll generate a primitive. So here we are having sketch. So create, we take a primitive that is cylinder. So instead of add material, make it frozen. Now base plane will take as the plane number 6 here, that will be considered as a base plane. X component, Z component we don't require. X component I'll put it 10, Z component will make it 0 here. So accordingly I will shift this in vertical direction. I will shift it by 5 here, and y component I will shift it by 70. So we'll see at this end. Now make it add to frozen and generate. Now go with the sweep operation, select the path that is this end, make it apply, and select the path profile we already selected. Instead of add material I will make it slice material, and then generate. So when you click on slice you will be able to see the object. Now when you make it show all bodies, that time you will see this is available at the inlet over here. So similarly we have to do operations on this side as well as on third side. So we are just going to create a three uh, such turns over here, and accordingly we are going to proceed. So first sketch has been prepared. Now we'll prepare the second sketch. So again you may hide all the bodies just by keeping the plane over here. So this is one way which can be done. So let's go to the plane again and have one more sketch over here. So let us say sketch 2, and let's try to prepare the sketch. Now again you can take the reference of earlier case also. Like if you take this as a reference, you can take the other dimensions also. Like first one 9.5 plus 19, so that will be equal to 27.5. Sorry, 9.5 plus 28.5, this is here. So this will be the point where we will start again. So from this take it horizontally, take a dimension that is equal to again 9.5 here, make it 9.5, draw a circle of okay, so here, then draw a line which is proceeding further till the vertical point. Dimensions of this will be equal to 51 here. Similarly take it on the other side. So this one is the horizontal line. Take it, insert dimension as equal to 51. So this is 51. Trim out unnecessary things which are not required. So go with the modify operation. Trim. This is not required for us. This is not required. This is not required. This is not required. This is not required. So one more time we have to do the same operation. So go to the create, say primitive, that is cylinder. Base plane you have to take again plane 6. So that is one thing that you have to make it clear. Add to frozen. Y component we need to take it 10. This one will make it 0. Then x component will be, this is 5 over here at the center. 5 plus 19, that is 24. 24 plus again 19, that is equal to 43. So we'll take the x component as 43 here, and this one will move it by 70 distance, so exactly it will be here. So again we need to follow the same path. So apart from that, the cylinder which is generated, first of all let's generate the cylinder. When the cylinder is generated, we'll hide all other bodies over here and we'll generate the path. So let's select the sweep operation, select the profile, make it apply, and select the path, make it slice material and generate. So when you generate, so it will look like this. So this will be second part which we had did. Similarly we have to do the third one. Let's generate the third one. On the same plane we will prepare one more sketch which will be on this side, sketch 3. So again draw a line So let's uh, first of all let's look at the plane here, then draw a sketch 3. So line, take it at a distance of 81 now. So dimension, I take it 81, this is for our reference. Then draw vertical line, that is again is equal to 19, as the dimension was 19. So let's take this is equal to 19. So from this again we need to go inside by the distance that is equal to 9.5. So select this one as 9.5, then draw a circle of radius 9.5 or diameter is equal to 19. So let's put this vertically. What will be the dimension here? That will be equal to 51. So same way on the other side also we need to make it 51. So here this will be horizontal. Make this dimension is equal to 51. So in this way, now trim out the unnecessary things which are not required. So this is not required, this is not required, this not. Now create the primitive that is equal to cylinder. Again, you need to select the base plane as a plane 6. Instead of add material, make it frozen. Y component will take it 10. Z component will make it 0. Now we need to shift it on the other side. So X component will be equal to 81. So Y component I will put it to 70. So this will be on this side. Let's make it generate. Now go with the sweep operation. So let's focus on this part. So click on sweep, select the profile, then select the path. Now instead of add material, make it slice material, generate. So click on this, you will see this one. So now I'll make it show all bodies here. So you can see here, so this is the cell in between, and we have we can say a channel in which the cylindrical objects are being prepared. So let's create one more object here like cylinder over here. So for this we need to make a primitive that is cylinder. Now again you can take a reference of the first case which we have took. So y component is equal to 10, then this z component is equal to 0, x component for this case will be equal to 5 plus 19, so that is equal to 24. So x component will be equal to 24 and y component will be equal to 70. So you can just see here it is generated. Make it frozen and generate. Okay, so we need to select the plane here to plane 6. So it will be generated at the required location. You can see here. Similarly, I need to generate at this location as well as this. So create primitive that is equal to cylinder. Select the base plane as plane 6. Make it apply. Instead of add material, make it frozen. This y component will make it 10. This make it is equal to 0. X component now will be equal to, so 5 plus 19 that is 24. 24 plus 19 that is 33. 43 plus again 19, so 43. 62. So make it x component as equal to 62, y component will make it as 70. So it will be at the required location. Similarly, we have to go get the last one, that is the third one. So select a primitive that is cylinder. Instead of add metal, make it frozen. This is 10. This is equal to 0. And now total is, it is 105. So I need to shift it by x component as 100. Select the base plane as plane 6. Make it apply. And sorry, this one has to be taken 70. So let's make it generate. So it is at this location. So in this way we have created this you can say the cells. Now what we'll do is, as per the geometry, this is further it is extended till 90. This is extended till 70. So these are in between are 70 and the end one are 90. So what we can do is, whatever the earlier cylinder we have generated, we itself can make them as 90. So instead of y component, would we took this is equal to 90. So this cylinder 1, I can make this component directly equal to 90 and I can generate. So you can see here it has been generated. So the first and the last one is 90. So we'll make it this is equal to 90 and generate. So first and last has became 90. The in between which we have, they are actually 70. So if you just check here, this is 70. So all of them will be equal to 70. So let's take cylinder 4. So y component will be equal to 70. Make it here, generate. Similarly, cylinder 3 is there, cylinder 4 is there, cylinder 5 is also equal to 70. Make it generate. Then cylinder 6 is also equal to 70. Make it generate. Then cylinder 7 also will be equal to 70. Make it generate here. So these are all up to 70. This one we need to transform this as the a kind of curve over here. So accordingly we might need some sketch over there to proceed with the object. So either one thing which we can do is we can take a reference of this, or additionally we can create a plane at this location. So both of the options have been available. So accordingly whichever is preferable, accordingly we can go with. So if I create a plane over here, so plane let us say I'm taking it from plane 6. So in that case I shift it the plane 6 in x direction by equal to 5. Then I shift this z component, that is equal, sorry, y component, not z, y component as, so my total distance is here is 70 plus 90, so that is equal to 160. So I put it here 160, so it will be at the required location and make it generate. So this is one way of doing the things, so that you can proceed with the easy process also. So now from this I need to draw the sketch. So if you see this one, radius is again 9.5. So draw one more sketch on the plane. So here click on this line. So let's draw a horizontal line. So the dimension will be equal to 9.5. So make it 9.5. Go vertically one more line, that is equal to 9.5, or directly you can draw a circle out of it also. So make it 9.5. Draw a circle here, that is equal to, let's take it the dimension is equal to 19. So it will be exactly from this. Draw one more line which is coming from this in horizontal direction. So what will be this dimension? This is 76. So you can directly took this as 76. So put this as 76. Now again you may draw one more line which is coming here vertically. Take the dimension. Okay, so the dimension, no need to take the dimension. So draw a circle here which will be corresponds to the same radius. Trim out unnecessary things which are not required. This is not required, this is not required, this is not required, and this is not required. So the things which are not required you just trim out. Okay, so unnecessary things which are not required we just trim out. Now it is need to generate a kind of sweep operation. So again we need to select a path here. So select this profile. So select this one and then select the path, make it apply, make it add to frozen and generate. So you can see the path has been selected and generated. So in this way this portion has been generated. Similarly, we need one more plane at this location in order to generate this kind of curve over here. Similarly, we will generate a curve over here. So one another thing is we can create one more sketch over there on this plane 7 itself, or additionally you can create one more plane also. So both of the way options have been available. So what I will do is I will create one more plane, and this is again from plane 7, I guess. I will take the x component, let us say by 19. So take it 19 here, and then I will take the y component is equal to say 720. Okay, just a minute. So 90, this is 70. So this distance was equal to 70. So 20 distance will come down. So here I will come down by offset minus 20 here. So it will be at this location. Let's make it generate one more time. For this plane I will generate a sketch. So first of all, go in horizontal direction, take the dimension as 9.5. Here try to draw a circle directly. Circle, take a dimension that is equal to 9 point. Okay, by default it has came. So trim out unnecessary things which are not required. This is not required, this is not required. Just go inside and let's have path and profile selection. Go with the sweep operation, select the profile, this is profile, select the path, this is the path, make it apply, make it frozen and generate. So we have generated this one. Similarly we have to generate it for the other part at this location. So again we need to have one more option, that is generating the plane. I offset this plane by x distance, that is equal to 19, sorry not 19, 38. So it will be at this location. So I will generate this here, and on this now I will try to draw one more sketch. So this is at plane 9, and I will draw a sketch here. Let's have a line from this horizontally, take a dimension that is equal to 9.5, then draw a circle of radius 9.5. Trim out the unnecessary things which are not required. So this is not required, this is not required. Just have zoom in and try to do the sweep operation. So select the profile, select the path and make it generate. So instead of add material I will make it add to frozen and generate. So same way we have to follow in the other one also. When you do the sweep operation, make it add to frozen. Yeah, so in this way we are trying to generate a kind of arrangement where we have kind of the lithium-ion cells which are been separated by one plate, which is used for taking the heat away from the cells. So this is how the model has been generated. Now it's time to give the proper names to it so that we can proceed with the next part, that is related to the generation of we can say mesh, another part. So first of all let's have this one. So I will denote that as a cell. This second one also I will make it as a cell. This is your plate which is enclosed. I will write this as a mid plate. This one, your pipe is there. This is also your pipe. This is your pipe. This is this, all this. So I will make this as a unite boolean operation. So make it boolean and unite. So in this way what I have is the cell and then mid fluid, and this is your solid. So instead of that I will make it the fluid zone. I will make this also as a fluid. So here we have generated this. Now we'll be applying heat in this region, and accordingly we are going to generate the mesh, and we'll proceed the next part. Now there are two ways. One is we can provide the convection at this surface, so that is one way of doing the things, or we can separately define the condenser zone also. So both of way the things can be done. Here we have a cell, we have mid fluid, and we have as a fluid zone. So both of way we can proceed with. If it is a pulsating heat pipe, you might again slice the geometry in between, and accordingly also the further operations can be done. So what I will do is I will create one more plane. This will be again from base plane. I will take as ZX because I need to slice the geometry in this direction. So this is a plane, not from centroid. I will make it plane. Instead of XY I will put it ZX, make it apply. I will transform this in Y direction, sorry, not Y, Z direction. So put it to around 70 from the bottom, 70 is here. So let's take it 90 from the let's make it generate and do one operation which is called as slice. So make it by plane 10 and slice. You can see this has been generated. So you can either put condenser on this region, that is one way of doing, or you can actually make this zone which will be either for the fluid which has been filled or the fluid which is not been filled. So this one we will consider this as a fluid which has been filled, that is the working fluid, and the remaining portion we will consider it as the portion which is having air. So here we are done the slice operation at plane 10. Create one more plane. It will be from base plane Z. Make it offset, say 20, and now generate. We'll do the slice operation. Okay, so this is we'll consider. So why am making this as a one part? I'm making this as a part where we haven't have the fluid filled. So uh, this is the portion where the fluid is actually filled. This is the portion where the fluid is actually filled. So you can make this as the say we take it water. So let's denote this also, like this portion is filled with water, this is also been filled with water, and this last one is also filled with water. So this is air zone, this will also be air zone, this will also be air zone. So all this will be air zone. This zone is actually specifically for your condenser, where the condensation will take place. This cell will make it form new part. So let's denote this as a cell. It should be solid. This will be mid plate. This is a fluid zone, fluid zone, fluid zone. Make it form new part. Rename between W and E. So I will make it button water and A. This is the zone between water and air. So I am giving the name so that I can differentiate this in the latter part. Or you may say some adiabatic zone also. So this is okay. So this is a meat plate. You can see here. This air meat plate should be solid. The air should be fluid. Then water it should be filled as a fluid. The cell it should be a solid one. Between water and air it should be a fluid one. So this is how the geometry preparation has been done. Now we'll save the work. Prismatic. Make it edit. So we have opened the mesh. So first of all I will generate a default mesh to understand how the computer will prepare. If it is not with respect to the expectation, I will make it slightly finer than this so as to have a quite better results. Okay, so not that good over here, so we'll make it somewhat fine. Right now the elements are around 4,08,300. Okay, so I will make it 0.001. Let's make it generate. We are not that worried about the very fine mesh on the cells. Preferably where the fluid zones are there, we want a comparatively finer mesh on that side. Okay, so this looks to be better one. Yeah, it looks to be better. It might not be very fine, but still we'll go with this so as to reduce the time required for the simulation. So now once the mesh has been generated, we'll define the cell boundary. So whichever the heating zone is there in this region, so that we'll specify. So first of all, I will click on the cell. I will say hide all other bodies. So I select the internal faces of this, and for this I will specify the zone. So create name selection, I will put as a heater here, where I am going to apply the boundary condition heated zone, or I will say the as a heated zone, because heat will be transferred from that wall here. So first of all, we have specified the heated zone. So show all other bodies here. Now next thing is uh, whichever the heated zone we have specified, so accordingly the heat will be transferred to this part, and from this also heat will be transferred to this part. Now I will select the hide all other bodies. So this is the portion where the water will be present. Okay, so heater zone will be already as specified, the water is present in this region. So this is the portion where the condensation will be takes place in. So I will make this as condenser. So this is your heated zone, and this is your condenser zone where the heat is likely to take out. So in between that the fluid is likely to flow, and accordingly we are going to have. So I'm not applying any other boundary conditions rather than this. We have applied the heated zone over here, then we have specified the condenser at this location, and then I will make it update. Once you see the mesh translation to fluid was successful, I will just close this meshing part. Open the setup. So depending on how many processes you have, accordingly you can set. I will select the transient model. Gravity I will specify minus 9.81 here. Then model, you need to turn the energy multiphase equation volume of fluid method implicit body force. I will turn this on. Close this. Energy equation I also need to turn it on. Make it okay. Yeah. Viscous K epsilon, enhance wall treatment, thermal effect and curvature correction. So all this I have selected. Now material you need to select. So I will go to the fluent database, water liquid and water vapor, that is the two things I will copy. Make it close, make it close. Solid I will put the pipe as a copper. So fluent database, I go with the solids. I select the pipes are made up of copper, then close, then close. Again the cells are actually made up of nickel, means the outer cover is actually made up of nickel. So one more thing which I am adding over here is nickel. So sorry. Let's check. Yeah. Okay, so now we have generated this three. Go to the model again, multi-phase volume of fluid. I will select the phases. So primary phase I will select as a steam. So here I will select the water vapor, make it apply. Secondary phase I will select as a water liquid. So you may specify here water liquid, make it apply. Then constant I will put it 0.0736. Surface tension, force modeling, wall adhesion, jump adhesion, make it apply here. Okay, then so number of mass transfer mechanism, put it 1. I will say water to steam. So here water to steam. So evaporation condensation, let us say it is taking at 0303 Kelvin, make it apply and let's close. Yeah, now material selection has been done. Cell zone conditions, you can put it the air between this one, the cells they are made up of. The cells you may select as a nickel here. Nickel, make it this one I will say copper, then close here, then boundary condition. So where we are applying the boundary condition, so first one let's check out for condenser is there, then wall cell, so wall cell is there, so heated zone also again I put it here, some boundary conditions as temperature, let's say 323, make it nickel, make it close, so let's make it close here. So boundary conditions applied only at one place. For remaining walls you may see here at condenser we are not changing anything, only the angle of contact we may change, that is equal to 20, here make it apply. So you have to do this for all, so make it 20 each and every location. Okay, is not there, so wherever it is applicable you make it 20. So this is mostly applicable for your pipes only, so wherever you observe it you just put it to 20, the contact angle. Let's make it 20. So make it 20 here. Wherever you are observing contact angle at this location, you have to specify this. Okay, it is not there. So go to the initialization. Go to the patch, water volume fraction 1, patch with the water, close, row to run calculations, let's say 20, solution animation. So new object contours, I will say temperature instead of I will say total temperature out there. So close this one. In addition to that, you can say contours of volume fraction also. So here I just go with that contours temperature. Instead of that I will select phases, volume fraction, let us say water. Specifically for whatever your walls are there, that you can specify, especially on this. Make it float, apply, then close, say display, and say this is also close. Select contour 2 and close. Now run calculation. I will say adaptive time step instead of fixed time step. Let us say first 10 I will take 0.05, and let's click here and generate. So the iterations will last for some long duration, and then we'll be in better position to visualize how the phase change has been taking place, where the condensation is taking place or not. So this is one of the animation window we open, that is for the understanding how the phase change has been taking place in the pulsating heat pipe. Second, one more window that will open, that is for your total temperature, how the variations are there in the temperature, so that we can observe. So that will be another window will open, that is real contours of total temperature. Second window we have the contours of volume fraction water. We might have to run this for longer time because we have selected the adaptive time step, and initial time step size also we have selected 0.05. So time required will be considerably more, because there are chances that the problem of current number can happen, and we don't want the simulation to stop in between. So that's why this is one of the things which we are going to follow. So we'll wait for these calculations to visualize how things are changing. Here receive the floating point exception error, so we need to reduce the time step size further. So we need to change this time step size, let us say 0.005. Go to the initialization again, click on initialize, make make it okay, and then you have to run calculation again. So earlier we have took the smaller the time step at 0.05, then 0.005 we had taken, but both of the times the problem of current number appear. So we took 0.0005 and then we have started. So for the earlier 10 time step it is working very well. So let's show you with again, but with this time step the simulation will take very long time. So ultimately we don't have any option because there can be a problem of current number, and that's why we have to 0.0005. So with this there are uh, probably less chances of problems of current number. So we have run this simulation for almost long time. You can see here uh, we have took 0.0005, and you can see the number of iterations which are going on over here. So they are quite higher, so around 8822. As I said earlier in the previous one case where we took a very small value, and that's why it is likely to take more time, and till now we haven't seen the problem of current number. So that is one good thing for us, because we took this very small time step size, but again definitely the time required in this case will be quite higher. So we have to run this simulation for a long time. It's maybe for around 24 hours or so, so as to get a considerable we can say the development of fluid flow and other thing. So you can see in terms of temperatures here, so the temperatures are quite variations can be easily observed over on this we can say window, but still that is not sufficient. We need to run it for longer time. As I said, only 8845, this will not be sufficient to observe the entire contour. So definitely it has to be for higher number of time steps. So this is one of the way by which we can say the simulations has been carried out. So we might need it to run it maybe around 1 lakh iterations, then probably we'll see a considerable variation in here. So as of now it's very less, so we have to wait it till the long iterations. So it is around 463 time steps you can see.